Hi, I'm Siqi Liu, and my partner is Yiming Shi. Our project is on ensemble reinforcement learning, where we apply ensemble methods on RL agents in MetaDrive. To begin with, ensemble learning is widely used in classical machine learning. So we want to investigate if combining different models will improve their performance. The model we investigated are PPO, TD3, GAIL, and SAC. And we also investigated a variety of ensemble methods, such as averaging, majority voting, and also training a weight selection model using reinforcement learning. For the four baseline models candidate models that we mentioned above, we show their average rewards, and we also visualize each of the individual models. And these are the next two. So as a start for our ensemble methods, we created a weighted average model where we average the actions from each of the submodels with a pre-specified weight. And from what we can see here is that the ensemble model does perform a little bit better than the average of each of the submodels, but they are generally not better than the best of the submodels here. And we also visualize our average model using our visualization scenario that we showed before.
Plainly averaging the actions from different models may actually not making sense. Take the following situation as an example. Suppose model 1 wants to turn left and model 2 wants to turn right. If we just averaging their actions, it will yield like actions going forward. But actually the model 1 and model 2 actions are trying to avoid the cars in front of the green car. So if we averaging it and use the result as going straight action, you will hit the front white car, and that actually doesn't make sense in our environment. So in order to kind of fix this kind of problem, we introduce a human defined strategy. The strategy is described as follows. So basically, our observation will first pass through several baseline models, and we'll count how many models are going to turn left, how many models are going to turn right. If more models are turning left, then we're only averaging those actions are turning left. So in this way, we are not canceling the turning left and turning right when doing the average. We also test these models and compare them with the baseline models of naive average. So we find that for the combination of TD3, PPO, and SAC models, we gain better rewards, but for the PPO TD3 Gale combinations, we actually get worse rewards. So basically, we can say that the rewards are not getting better or getting better in some specific case. So we also have the visualization of it. We can see that this kind of visualization is pretty similar to the naive average method. So notice that for all the previous models that we're trying to improving using Ensemble method, it's kind of assigning the weight we think is the best for different models. But one thing we can do to improve this is that instead of using a human-centered weight or human-centered strategy, we can actually learn the weight using RL models. So in this new method, we're going to train our RL models to learn a different weight assigned to different baseline models. So suppose we are getting an observations. First, we'll pass these observations into the baseline models. For example, we have PPO, SAC, and TD3, and we'll got 3 different actions from them. So we're training another PPO selection models that based on this observation, they're trying to assign different weight for the actions outputted from these baseline models. And we are doing a weighted combination of these actions, and these will be our final actions. So this is the training curve of combining based on TD3, PPO, and SAC. We can see that in the training phase, we can get really high rewards in very small iterations. And also, this is the evaluation results. We can see that actually our card is kind of able to finish our trail in this kind of scenarios, which is really good. But there is still some randomness because this is one of our selected environments. And also here we show the different weights we're using during different phases. So basically we can see that our selection models are trying to assign different weights to different models. So basically since all these models have very similar performance before, so basically we can see that sometimes the models are prefer Gale, sometimes they prefer SAC, sometimes prefer TD3. Previously, the baseline models we choose are just different kind of RL models, but we can also consider the same RL models, but are trained on different environments. So in this case, we train several different PPO models based on different environments. We train one PPO models which only train on straight environments, so it will focus on making the card going straight. And also we're also train another PPO models which only focusing on the round and the circular situation. So basically the models are trying to learn going circular roundouts or circular roads. And the third models were only trained on intersections and turns, and we're making these models focusing on turns. So we are going to train another ensemble method based on these 3 different models, and we want the ensemble models able to choose the best models in the 3 when facing different environment situations. So basically this is our training curve. We find that it also reaches very high reward in very small iterations, but actually the evaluation rewards and the training rewards is not very high. And also sadly we find out that actually the trained models cannot choose the best thing from turn, round, and straight. When they're just doing, then the card is working on the straight road.
Next, we have also created an ensemble model with different traffic situations. We intend to create an environment that has different lanes and different traffics. So we split our environments into 9 sub-scenarios where we have different number of lanes of the roads. So the roads can have 3 to 4 lanes. And we also have configured different traffic density. So there may be 1 car per 50 meters to 1 car per 200 meters. Then we create an ensemble model by training a weight selection model with PPO to train on this hybrid model that have different number of lanes and different traffics. For comparison, we also train an ensemble of 9 different submodels, each trained with PPO on this generalized scenario of different number and traffic density together. So the results is that we can see that the ensemble models performs much better than the single models. However, we do not see that the specialized ensemble performs better than our generalized ensemble, where the specialized ensemble is having each of the submodel trained on the specific lane number and traffic density. And we have also visualized our specialized ensemble on the scenario that we just showed before, but this time with 4 different lanes on the road, and we also show the weight of each of the submodels. And we can see that in different situations, the model will use different weights to combine the actual action that is being outputted. So we are able to hopefully perform better. For future works, we want to try more baseline model to ensemble with. And also we have created ensembles for the ensemble with different traffic scenarios. We want to try setting different reward ways for different scenario. So for example, for heavier traffic and less lane numbers, we want to give them higher rewards to encourage our model to learn better on these kind of hard models, instead of just giving it up and try to get all their rewards from the easier scenarios. Also, we might want to use the MetaDrive safe driving environment to allow the car to continue after crash, just with some penalty rewards, so that the rewards at the end so the rewards between the easier scenario versus the harder scenario are comparable. Lastly, we want to train our submodels and meta models together, so that we might be able to use boosting method to get even better performances. And these are our reference. Thank you so much for listening.